Okay, we have 30 participants and let's get started. Good afternoon, everyone, and warm welcome to this afternoon session from Women Who Code Bangalore. For those who don't know what Women Who Code is, Women Who Code is a global non-profit organization which is dedicated to inspire women to excel in this technology careers. And the vision of Women Who Code is to empower women and to build a world where the women are proportionally represented across all the levels in the uh, tech industry, right? And we do have code of conduct, and Women Who Code is an inclusive community encouraging and empowering everyone who participates in and supports our community, right? Irrespective of uh, gender or expression or ability or physical appearance, yes, uh, we are inclusive. Our events are intended, as I mentioned, as to inspire women to excel in technology careers, and anyone who is there for this purpose is welcome. And for those who wants to feel like being with us and become one among us, you can be associated with us as a presenter, as a facilitator, or even as an audience as you're doing right now, right? And if you want to get to know more about the upcoming events about from Women Who Code, then you have this meetup links, and we do have the other social links as well for you to connect, and you can write to Women Who Code team. I shall provide you the mail ID in the chat, and you can reach out to us, right? Having said this, I take quickly introduce you to our speaker of today, Minnie. She's a technical staff from Dell Technologies. And about Minnie, Minnie works with Dell Technologies Bangalore in the area of firmware and security. And she holds an MTech in embedded systems from BITS Pilani and a degree in computer science and engineering from the University of Kerala. And she has more than 25 years of experience in defense, semiconductors, consumer electronics, substation automation, and industrial measurements. Right, and starting from her master thesis few years ago, she has been trained intensely in cybersecurity with a loving guidance and encouragement from her Guruji, Dr. Ragnar Skjærhals. Sorry if I'm pronouncing it wrong. And he is the head of cybersecurity industrial automation ABB. And she went on to complete certifications in cybersecurity and publishing papers, file patents, mentor aspiring cybersecurity engineers, and engage in various cybersecurity activities. And she loves to speak on cybersecurity in variety of forums. So let's hear from Winnie on secure your IoT challenges and way forward. Over to you, Minnie.
Thank you, thank you. Thank you for such a beautiful introduction that you have given. I guess I will start sharing my screen.
Yeah, sure.
Yeah, I think you may have to stop here. My screen is there?
Yes.
Okay, thank you. So thank you all of you for joining in. I see some familiar faces. I'm more than happy to see that at least some people are known to me and familiar to me. And this afternoon time, thanks for your attention and your interest in learning cybersecurity. And I'm not new to Women Who Code. For over quite some time, I've been giving various sessions on primarily on cybersecurity, and some sessions also on some of my hobby interest topics. You could see in the Women Who Code YouTube channel. I also encourage you to go and take a look at the recordings that are available in Women Who Code channels. There are quite interesting sessions, some from me and also from a variety of other people like you. And so let's start. Like how Nirupa was telling, I'm reasonably recent in Dell, and this representing Dell. This is the first session that I'm doing for Women Who Code. So thank you for all of you coming in. It's also interesting for me to share what I know to a larger audience and also to those who want to learn cybersecurity, because I truly believe that security is a collective, which many people develop that expertise and the passion and commitment towards it. That is when we can achieve security. So let's start today. Today we will talk about IoT security. That is more to do with in the Internet of Things, the things that we are talking about. That is a world of physical devices which will be very close to the hardware, and the range of that could be varied. Some could be like very minimal with a very minimum computing power, could be like light bulbs or all that. And it could also be things which are at the higher end of the spectrum, which has multiple processors and multiple CPUs and which has higher computing capacity and communication. We can run elaborate protocols, crypto, all that. So that is other end of the spectrum. So today what we will cover is, we will cover the architecture, how an IoT system looks like, and we'll also explore few of the commonly used communication patterns, and with respect to security, what challenges are there, and more importantly, what's going on in the industry, what recommendations are there from various industry bodies, and where you could go and pick best practices for ensuring security in the IoT world. I don't intend to go into the details of the best practices told by each of the industry bodies, but definitely I'll give an introduction into where you can go and pick more information and what are the best practices, what is the various industry bodies talking about it. Those are the things that I intend to cover here. So let's proceed. This is how a typical Internet of Things architecture will be. If you look at here, on the left side, the red line shows your internet boundary. And on the left side, you see a lot of things which are called, which we call as the things. They could be at home or factories or even locomotives. And sometimes it can be mounted in a ship. It could be in the wind. All those are the things which we are talking as the things in the Internet of Things. How do they communicate? There are varieties of architectures for the plant infrastructure itself, that is from varieties of domains. Like if you look at, say, industry, the industrial automation, those industries, if you look at, there are references like, say, 62443, the Purview model architecture. How do you put layers of the things at the lower layer, and then maybe you will have your remote terminal unit, and then your control system above that. Those are some kind of architecture that would come in. And if you look at some other systems like, say, a power system, there may be different architecture. So in this diagram, I'm abstracting out all those architecture details of how these things connect and communicate over the local network. But we would assume that there would be some kind of a local communication that is possible here, and there would be humans who are controlling, that is people, and an edge gateway, which is talking to the internet boundary. So what we are trying to achieve is, we want to streamline the communication so that we don't have too many talking points from the local network, which is typically behind some kind of protected environment, and not that open towards the internet as what we see the web services in the internet hosted places, cloud hosted places. So the edge gateway segregates that local communication to the internet communication, and then you have the cloud. Usually that's what happens. From the cloud, you could pick out various applications that will take the data and then do your analytics or predictive maintenance prediction. There could be various algorithms that is done there to calculate and then see the future, also for primarily also for monitoring what is going around, health monitoring. All that is what you will see it in the cloud hosted application. This is what we are typically calling, when someone refer to us Internet of Things. The architecture looks somewhat like this. Not everything will be in the same manner, but most of the time you will see various elements of this, or at least few of them in the system. That is where we speak where the security elements are coming in. In today's session, we don't intend to cover all of what we are talking about in the picture, but we will focus more into the things part. That is towards the left side, what all are there, how can we secure elements in the left side things part, which are more close to hardware, the embedded system devices, which are sometimes resource constrained. Sometimes it may have more other constraints like power or even the computing capacity itself. And when we look at the edge, that could be some kind of a hardened gateway that is used for edge. Could be some of those our Dell edge devices, which you will see. Some of those could be the examples that you can think of, or various other companies also. They have their own identified edge devices. The edge, what you will have to see very carefully is they are typically dual homed or multi-homed environment. Like they don't talk to one place, they talk to the reasonably or relatively secure place that is on the isolated place that is in the local network. At the same time, it also talks to the public cloud infrastructure. So when you talk, these are to be taken care that they are dual homed. So they also act as entry point for from multiple network domains. That's in, which means which has different levels of security protection, which has different levels of security threats, and so those are the challenges that would come when you are designing an edge system. And now let us continue. I will take you through some of the typical communication patterns that you will see here. If you see this diagram, I have not drawn very specific communication diagrams, but we will explore few of those communication patterns in the next few slides. So you can look at one of these. Here, this is a very simple network. The device is there. You may be communicating to the device using an app, that is a mobile app, or a PDA or whatever. That could be somewhere within the local network, and a human being could be controlling that. This is one kind of communication pattern that can happen. Here you will have various challenges because the mobile, how hardened the mobile is, how the app is maintained, all that will come into picture. And in certain cases, which can even be an oversimplification, can be the human user may be directly interacting with the device. Because if the device has an HMI, a display, and a keyboard, sometimes most of these devices can also be faceless devices. It may not have a place for keyboard entry and a display. In those cases, this mobile and this use case will come much more handy as a communication pattern. And the next one, what you see there is another simpler communication pattern. But the security concerns there are not that simple. What you see on the right side, the human user is interacting with the physical device, and the physical device might be sending data and receiving data to a cloud environment. So that means it's not in line with the very first architecture where the communication goes via the edge, but instead it is directly talking to the cloud. So some examples that we could see is the first case. It could be that the device is enabled with the local communication interfaces like Bluetooth or NFC, or sometimes it could even be Wi-Fi. That could be one way where the app is talking to the device. In the second case, the device itself is talking to the cloud. That could be environments where they are enabled for public communication. That could be via the device itself may have an Ethernet and Wi-Fi. That could be one way, but then it may be going through intermediate routers. But it could also be that the device has communication technologies enabled like 4G, 5G, narrowband IoT. They are all SIM-based protocols, SIM-based communication protocols, which can be used, which can directly talk to the cloud. So there the risk will become high there. That is a pattern that we see. And this is another pattern that we are seeing, which is slightly more complex, where the user is coming, user is talking to the device may be in turn talking to an app. The app may be talking to the cloud, not the device directly. And then from the cloud, the data may be picked by another mobile application using REST APIs or such kind of standardized APIs, and then displaying it to a user, and the user may be interacting. So the user interaction goes via the mobile application, via the cloud, and even in the local communication. What to note there is, in the local communication, you have a mobile app coming in, which acts as communicating to the cloud as well as to the local. So the edge that we were talking about in the previous case, so this app act as an interface between public communication and the local communication. So we are coming to a situation that the elements of risk that is coming in may not be only in the device, but it could be coming from the app, or it could also coming from the cloud. And on the right side is another similar scenario where the device may be talking to an edge, and then you use the edge for communicating to further. So these are all patterns that you will encounter usually in the Internet of Things world. So the security concerns can be variety. Sometimes the device in itself is directly talking to the cloud, that is public network. or it may be talking to an edge, or it may be talking to a mobile application. So the risk elements involved will be variety. We'll explore one more pattern. This is not an exhaustive list of patterns, but we just see few of them for examples. So this is another pattern where the user may be interacting with the device. Then you have a mobile application that is talking to the device again. And then you upload data to the cloud. From the cloud, you pick the app and then do it. Sometimes it need not be a mobile app talking to the cloud. The cloud itself may be exposing a UI-based application, which anyone can open from a browser and use it. Or if sometimes it can be a REST API kind of API-based application where you will need another app to display. So these are all the kind of patterns that we usually see in the Internet of Things world. I guess you get a feel of what we are talking of, and now how do we secure in all these risks that will come into the device? How do we protect this communication? And as I told in this talk, today's session, the focus is on the device part. And let us look at some history, what is going around out in the world. It's not too much of a history, but a reasonably recent events that are happening. The attacks which are happening now, it's not only on the application per se, but also on the physical devices. There are cases where the physical device itself can act as a Trojan device. It may be running a malware. It may be running a compromised firmware inside. All those are cases that are coming in, or it could just be that there are vulnerabilities in the device which are exploitable and somebody is exploiting. I took two items here. One is this break tooth that is put there, that is on the Bluetooth, because it is getting into a crash by using this vulnerabilities. It is a series of vulnerabilities that are there in the Bluetooth stack. In some, like it's affected for many Bluetooth suppliers, okay, Bluetooth stack suppliers. And you can compromise the device. You can do DDoS attack onto the device, or it is also possible to run remote code execution by exploiting buffer overflow kind of vulnerabilities. So this is a series of vulnerabilities that are disclosed, which is known as this break tooth attack. This on the Bluetooth handshake, compromise on the Bluetooth handshake. And we'll also see the second one that is on the botnet, Mirai botnet. It is there for quite some time, but it keeps reappearing, and then forms and varieties of it keeps reappearing. So there was another reappearance of this Mirai botnet. That's the reason that I put here. Botnet, in case you are not familiar with the term, it is a network of devices that are infected by malware under the control of an attacking party. So that is what we call as a bot herder, who has a control on a network of device. And this network of devices might be having a malware inside. So they are used as a bot to launch further attacks of DDoS, like distributed denial of service, or you can launch further attack on the network. So these are a little bit more towards the more impactful kind of attacks. That is what we are talking here. Yeah, they can also be used for spreading those bots into other devices or other networks, and then spread that further. So this is, you are reaching to a situation where a whole number of devices are under the control of that adversary. That's what we are coming there. So it is all to tell you that the IoT security, the security at the device side, is something which needs an attention. And there is a lot of industry activities going around there. And it's not that it is not real, it is very much real. So now let us go a little further and then see in the context of all these, how devices, the individual devices can be affected, what is their life that is happening, and where all there can be problems, and then how to safeguard them, what are the kind of security threats that can happen onto the device itself. So the diagram that you see here, it's a typical life cycle of a device. Like when you see a life cycle, I've shown you all this supply chain as well as the life from birth to decommission, birth to end of life. That's what you are seeing here. So what happens is typically it is manufactured, and then it goes through supply chain, various supply chain. It could be like in between there may be integrators, in between there may be people who take it and then configure it further, and then add more configurations into it. And then further, ultimately, when I say provision, it is placed in the operating environment. If it is a factory, it is placed in the factory, and edge in the factory, it is sitting there, and then it is actually doing its operation. That's when the actual operation is happening. That is when you call it as an operation. So there could be problems that happen from anywhere across the cycle. So it could be at the manufacturing time. Maybe if you have an outsourced manufacturer person, it could be that they are not trustworthy and they are overproducing devices. That could be one, more than the contract. Or along anywhere else, it could be forging, and then it may have the same look and feel, but then it may not be running that secure firmware that is created by the manufacturer. Or during the supply chain process, someone could be changing it. They may be tampering with the firmware or even the keys that are provisioned into it. It may be maintaining the look and feel, but then it may not actually be the original device. And then it may be that the integrators and the people involved in the supply chain, they might be adding more configuration into it. So the configurations, are they secure? Do they have authenticity and integrity when we put such configuration into it? Even during the provisioning process itself, can an adversary come and connect a device which is not a trustworthy device into the network? So does the network accept such kind of devices which are under the adversary control into the network? Will your network and your system accept it? That is one way. Or do you have a verification where the device that is coming in, are they genuine or are they good? Are they coming from the right manufacturer? Should I trust the device? How do we establish the trust before putting into the network? That is one another challenge that happened. And during the operation, it's doing its useful functions, what it is supposed to do. And then management is our next challenge that comes. Management means over the period of time, there may be patches that are coming in, vulnerabilities disclosed, or you may be upgrading that for additional features. It could be due to security vulnerabilities or even functional issues. So at the time of management, during the life cycle, you will have to do firmware update. When the configuration, you may have to update. Probably there are some changes that are happening in the installed environment, and due to the installed environmental changes, that is maintenance that is happening in the installed environment. You may want to have other changes that is happening. All those are coming into the management part of it. That is the life cycle activities during its life. And then you have your decommission. Decommission also, you have security flows that can come in. Like, did you dispose of sensitive data, which can get into the control of adversary? Did you put keys? Even the data protection comes very much into picture when we are doing this decommissioning. So those are the life cycle that we are talking here. And there can be security challenges at any of these phases. That's what we are seeing here. It could be the identity and authentication, both the human as well as the device, and even the applications, like, are they identified correctly? Are they authenticated? Access control, like, do you have the permission to do what you are asking to do? That is your authorization. And the protocol security itself. Are we using secure protocols or there are insecure protocols? Can someone make use of the secure protocol due to flows in the implementation for an adversary to take control, or whether it is to control the device or even to do this kind of, what do we call, information disclosure? Like, can someone pick it and then make sense out of the data? That is leakage of data that happen. And privacy, that is again in the same manner, but there are multiple concerns of privacy, user privacy, the device privacy, the keys, data, all of that. And then trust establishment across various devices, how that will happen. Fault tolerance, if one is failing, how will somebody else take it over and then continue the function? All those are the challenges that we will face in this kind of an environment. And this is also an elaboration of the thing lifecycle, similar to what I have told. This one is coming from the RFC, that is IETF spec 8576. That is what you are seeing here. So in this situation, it's showing its life of device. That's, you may have a bootstrapping phase, then you have operational phase, and again you will do maintenance and re-bootstrapping. That's another way of in between configuration changes. Once again, it gets back into the operation. Again, you may be doing as part of maintenance and re-bootstrapping. And at the end of all that, then you may be having a re-ownership, that maybe you may be cleaning up all the data and then giving it to another person for using. Or it could be decommission and then discard. That also could be one way. So this is an elaboration of whatever you have seen in the previous picture. I see some messages in the chat. I'm the first time attending. What is the YouTube channel? Okay, we'll see it later. So this is one logical pause point for me. If any of you have any questions, we could take those questions and then continue. Nirpa or anyone else, if there is any question, we will see. Otherwise, we'll continue to the next topics. Looks like we'll continue. Okay, so here we will tell a little more in detail what are the kind of security threats that can happen. I will do a run through. This is not an exhaustive list once again, but some of the sample security threats that can happen. So the first one, what we see here is a vulnerable software. Well, that is what we usually see. There are bugs in the code. That's what it means. Like which can be a buffer overflow, which can be authentication, authorization errors, or things that you have not done input validation, or you have not done your rate limiting. So somebody can just exploit those existing vulnerabilities and then take control of your device and do activities which are not intended to be done. That's what you are seeing it in the first one. That is a vulnerable software. And next is about privacy. Privacy can be of various ways. It can be like things like tracking the location and usage. That can be a privacy problem. Like, you know where you are, if somebody is roaming around, or where is the device that is actually physically located. These days, there are a lot of location tracking mechanism. Bluetooth also has location tracking. GPS is there. You can see where that is. And that's also a privacy that is losing. Like, where are you? That's a privacy loss. And traffic interception, that is another kind of privacy threat. These are only representative samples, as I mentioned, not really an exhaustive list. And another security threat that can happen is a cloning. Cloning means it is untrusted factory. Like they have the same look and feel, but then you created another one instance of the device because it was not taking care of the security, and then you created clones. The challenge with the clones is you can't trust the clones. The clones, maybe they are devices used for performing attack. It could be that they have a degraded functionality. So whatever the manufacturer specified, it is not able to perform at that level. And maybe systems are designed for working at the level of the specification, but then you are not able to meet those specs. That's another challenge. And there could be backdoors. So backdoor means an undocumented entry into the device. So when if a clone is made, the original firmware and the original device may not have any backdoor, but the clone may have a backdoor, which can be used for an adversary to control the device. So these are the kind of security threats. We will go through a few more of the examples. I would suggest, recommend that you look at this list, and then you can look for more details of these kind of threats in some kind of database, whether it is NVD database, or even Mitre. Mitre has that framework which is called attack framework. They also put quite a lot of details into all these kind of issues, how it can happen, what are the mitigations that you can do, how it can be prevented, how it can be identified. There are quite a lot of elaborate details available in that Mitre framework on adversary tactics. So I would suggest that you look at this list or the patterns and then go and have more detailed exploration on how these happen. Like more importantly, how can they be prevented? Okay, so let us look at the next challenge. Next security threat could be malicious substitution. It could be that you have just replaced a genuine device with a low quality one. Apart from the previous performance related items which I was talking about, it could also be a damage to the organization's reputation, because it's like you have a Dell piece of equipment, and then it may look like to the whole world that you have the stamp, you have the logo, it all looks the same, but then internally, ultimately, it is running some other malware because it is substituted for another similar look and feel. So these can be a damaged reputation damage that can happen. And eavesdropping is another security threat. That is, the eavesdropping could be on the security parameters, configuration, keying material. It can be on any of that. Like what can happen is during the commissioning of a thing into the network, it may be susceptible to eavesdropping because that is a less secure environment when you are first time commissioning it. Especially if you are talking about keying materials, the private key, the security parameters, configuration, and those kind of information. So what somebody can do is, after obtaining the keying material, the attacker might be able to recover the secret key established between the communicating entities. So by doing that, they can compromise the authenticity and confidentiality of the communication channel. So it might be that during your trusted phases of provisioning or trusted phases of commissioning, you might have recovered certain information which can be later on exploited for other activities which are malware activities, or even for getting the traffic which is later on during its operational phase. So all this can happen. So it's not to be seen at instance of time, but over a period of time, a compromise at one moment could be used for exploiting at other phase in the life cycle of the device. So that is what the danger for it. So even for this kind of understanding on how somebody can exploit this information, how it is like how an adversary can act on your system, there are quite a lot of patterns that are there. Like Lockheed Martin, they have come up with one kind of attack, like a modeling of how adversary tactics and how adversary can work off that. They call it a kill chain model. That's from that company, Lockheed Martin. So once again, I recommend that those who are interested into it, have a look at that. They are coming from the typical defense world, like how this kill chain, the concept of kill chain itself, like mosaic warfare and all that. That is what is the terms which is used in the military world. Like instead of using one element, you can use multiple elements for, like if you have your land, air, water, and added to that, these days there are other more dimensions that is coming in. That is from, it could be space or it can be cyber. There are other dimensions that are coming in. So instead of, so all of this together, use it as a mosaic for launching an attack on your system. So this Lockheed Martin has modeled that very well. So you could have a look at that also for more information. And then man in the middle or person in the middle attack, that's what you are seeing here. That can also happen during your commissioning phase, operational phase. That's another type of attack. Like it could be to gather your keys or to your data, like similar to what I was explaining. The phase of the information gathering need not be the phase of adversary making use of it. It could be at another time. We'll look at a few more of this kind of attack patterns. That is, one is on the firmware attack. Firmware attack is, this is what we are trying to prevent by using this hardware-based root of trust, secure boot. Those kind of solutions are what we use for firmware attack, for preventing that. It can be maliciously, somebody is replacing that firmware. Like when you do a firmware update, if you don't have your proper checks in place, instead of doing the firmware update from a software which has genuine integrity and authenticity, it could be a malware that is getting updated. See, that is one way. So these are all, it could be coming because you do not have sufficient defenses like hardware root of trust. It could be due to poorly maintained firmware. That can be, there are bugs or vulnerabilities inside which allow loopholes for somebody to get into. And then how do this, the next one is about extracting private key. Extracting private key can be quite sophisticated attacks also. Somebody might be putting some kind of probes into the pins, if in case the keys are going around on the board, or somebody may be taking the chip and then removing the cover and all that, and then maybe extracting information from the chip itself. It could be from the memory, or other information extraction methods that an adversary can use is side channel attack, side channel analysis. Side channel is like the power or the temperature, the thermal leak, all that could be based on what is the kind of computation that is happening. That is, if your keys are of certain patterns, that key pattern of the key could be revealed by observing other side parameters, like it can be the acoustic noise, or it could be the temperature, even the timing. All those can side parameters. You don't have to look at what is happening inside. You don't have to go into the bits and bytes, but without looking at all that, you can extract. Till very recently, one of my students who were there with me has published a paper. Maybe I'll give it later on how can we use acoustics and then some AI models onto the acoustic data extracted for extracting private information. So those are all kind of extraction of information that can happen. If they are physically unprotected, all this could become a challenge. And in physically unprotected is one. It can also be cases where if you have not really built in hardware root of trust based mechanism, which are per instance of the device, if you have common solution, which are going in for all instances, say you manufacture a lot of devices in one series, in one batch, and if extraction of private information from one instance can be used for launching an attack onto other instances. See, that is where this root of trust and all comes in. Like, it should not be such that a compromise on one piece of equipment should not be able to launch an attack onto other pieces of the equipment. So somebody can just pay and then buy a device, and then they can play and then do whatever they want, extract all what they want, which could be used for launching attack onto other pieces because they already identified a flow that could be exploited. And denial of service is primarily happening because of poor resource management, like memory and compute. You can send out a lot of packets, a lot of data into it, and then you run out of your resources. That is one denial of service. And next, I have put some examples of network-based attacks. That is your routing attack, sinkhole attack, wormhole. I would suggest, I don't think I'll have so much of time to get into all this in detail. Elevation of privilege, you have an entry, but you are only having some read access or view access, but then you are able to exploit certain flows and then get a higher privilege than what you are authorized to do, and then you do something else. So these are another kind of attacks that are there. Like you can attract or ripple network traffic. That is when you can redirect the network traffic to the where you want, so the genuine parties don't get it. So it can act as a denial of service. Once again, I'm at a logical pause. So if there is any questions, you could listen to that and then continue further.
Yeah, Minnie, we got one question. Maybe you would be covering in the
how to identify the threats before it can actually attack me. Are there ways of testing? See, this is where I'm not covering it today, but there are various ways in which you can identify these threats. One way I would say is follow the secure development lifecycle, so that your regular reviews, design reviews, architecture reviews, code reviews, static code analysis will capture them in case you have done such kind of mistakes. Prevention is another method that we should use. Prevention is primarily the method that we should be using for all this instead of detecting. But since you asked very clearly how to identify, I'm focusing on detection. Threat modeling is another way where you look at logically your system and then see what are the communication patterns. You could also do some kind of like what is coming in from the Six Sigma and those kind of world. A failure mode and defect analysis, like treat security as a failure mode and attack as a failure mode, a security failure as a failure mode, and then do an FMEA onto it. That is another method which you can do. And of course, your testing, your penetration testing. Black box testing, white box testing, the typical pen testing method. So it's not like one thing is there. There isn't any one solution for getting into all this. So you apply multiple controls, follow the definition of the principle, apply multiple control, apply multiple mechanism, follow SDLC, secure development lifecycle. Like if you are interested, there is Women Who Code has one talk of my recording available on secure development lifecycle. You can have a look at that. Do threat modeling. There are a lot of practices which are coming in, like ISC2 and all that, and even OWASP. There are a lot of practices which are told for securely developing your software. Follow those practices. Those practices has both prevention and detection methods for this kind of issues. And if you are talking about a deployed system in the field, you have already deployed it, has gone through all that. And if there is something that is happening, then how do I detect it? If that's what you are talking, then put your intrusion detection and intrusion prevention systems, so like say firewall, application firewall, network firewall, like this web application firewall. Those are another mechanism that you can use. Like, or it can be quite sophisticated ones like traffic pattern analysis, anomaly detection. Those are another way. Like log management, like SIM solutions. Like there are so many people who are providing SIM solutions, which are both based on data analytics and AI-based solution, as well as just applying basic statistics onto that. That is what you can use for in a running system. What can you do? So these are all ways you can do. Yeah.
Sorry. Minnie, we do have other question. What are ransomware attacks and how do it attack our IoT devices?
Okay, ransomware is, now it is too popular. Ransomware is okay. I hold you by neck, pay me money, I'll release you. Okay. The ransomware is somebody is taking control over your system. Like it can be onto the IoT, or it can be like you must have seen, right? Recently, the US, the Colonial Pipeline attack. You must have seen it in the news. There are a lot of ransomware attacks that are happening recently. Yes. So someone take control of your system. It can be like IoT means it's infiltration. If your IoT is not directly exposed to the internet, if you're going via the edge and all that, they can get into one point, they can get into, and then they can do lateral movement, horizontal movement, and then get into and then take control of your IoT device also. So in fact, they get the control of the whole system. That can happen. It could also be just your data, like hosted applications, cloud-based application. But these kind of IoT devices also infiltration, like once you get one hold, then you can move horizontal lateral movement. That is what the typical tactics that are used by adversaries for getting control of your devices. Because once you get into one entry, say your control environment has control over your physical IoT devices. Like I'm talking in cases where they are physically separated, whether they have physical protection available. In that case, like use this network attack and then reach into your system. So ransomware attack is okay, asking for money. But the thing is, the dangerous part of it is, I do not know. I don't have knowledge, but I'm not sure whether all the ransomware fellows are doing all their secure development lifecycle. So what can happen is that even if you pay the money, you may not be able to recover your system. They may release certain data, like encrypted data that they are keeping, but you may not be able to recover back entirely, completely as it was originally, even after you pay the ransom, because they themselves may not have control on what exactly has happened. So I don't know, there are various ways in which you can take care of these kind of attacks, and one of them is backup. One is typical monitoring what is happening to detect whether some adversary has infiltrated into your system. But backup and recovery processes, that is what, like if you look at NIST cybersecurity framework, there is one which is for the backup and recovery is, there is a process defined. Like even if somebody has took control of your system, are you able to do your disaster recovery based on the backup systems that are available? Like how do you do your disaster recovery based on a cybersecurity incident that has happened? So that is the school of thought there. I hope I answered you to some level. So ransomware, like there's a monetary deal, but that doesn't solve all your problems. Yeah, let's continue. So we have only much less time. So the next session, my aim is to introduce you to certain industry frameworks that are available there. I don't plan to go into details of each of them. It's more to introduce you to the frameworks. So you could go and have a look at what are they talking and how can you prevent all these kind of things. One which I have put here is the OWASP, which I think you must be quite familiar with it. Many of you who given attention to security. This is lots talked about in the context of web applications, like OWASP, web application security. But then OWASP also has recommendations for IoT security elements. So this is what the top 10 threats in the IoT world. This is coming from OWASP. See, guessable hard-coded passwords, because IoT devices, people may not be going and visiting them often. So the passwords may not be changed also. So for ease of use, okay, I will forget it. So somebody may not even change what is a default password. It may be left there. So those are all one kind of item. Network services are insecure. Your other ecosystem interfaces are insecure. You did not update. Like unlike your typical Windows machine, update is not that easy. So update mechanism did not happen. This is a top 10 that is put. It's not it's not that this is a exhaustive list or something, but this is a top 10, like similar to what you see it in the OWASP top 10 vulnerabilities. This is a IoT world OWASP top 10. Lack of device management, insecure default setting, which no one changes that default setting, then it continues. So this is one area which I would recommend that you look at for understanding these OWASP's IoT. There's an IoT, Internet of Things project from OWASP. They put all of these kind of things. And then we will look at some of the other topics that are being talked about by industry consortia. This is another world, which is the Industry IoT Consortium. They have something which they call as the Trustworthiness Framework Foundations. So they talk about what are the trustworthiness characteristics: privacy, safety, resilience, reliability, security. And the link is here. So you could look at the framework, how they have put here. So this is a diagram which I have taken from that Industrial IoT Trustworthiness Framework Foundation. So they talk about how to build trust into each of these. The chip here itself, this is all the hardware related item, what you see on the left side, how the OEM modems are working, how the modules are coming, and how the chip is secured, and then how to protect the software. You may have your hypervisor or like virtualization environment. All those are things which are talked here, and maybe your services. So this is entirely covering and then telling how to build this. So these frameworks, the advantage of this framework is various companies and various representatives and experts have worked on it, and they have put recommendations which are easier to follow. So we could go through these frameworks and understand what they're talking about. And then next one is Cloud Security Alliance. That I would again assume that many of you might be familiar with the Cloud Security Alliance. So they also have a recommendation which is for the security guide for the early adopters of Internet of Things. That is what the document name is. So you could look at that. So they also talked about like even the local communication, sensor data, control data, how do you do that? And there are a lot of examples here. So I would suggest that this next diagram is also coming from the Cloud Security Alliance. So what I would suggest here is they have a lot of examples from variety of domains, from healthcare, then proximity advertising, even a smart fitting room. So the recommendations are all in this direction, what you are seeing here, like how the classification is done, the elements of protection for varieties of items. One is like edge devices, how do you protect them? And gateways and applications, how do you protect them? And what can you do for enterprise cloud computing, cloud storage and data analytics here, how you can do. So this kind of application whitelisting, I just picked the diagram. I know that this whitelisting are terms which are not acceptable these days, but the reference document is still the same, talking about it must have been created at a time when this terminology may not have been that mainstream. So this is one area where you could look at how we can do all that. So they have put varieties of controls that can be put into place. The challenges and recommendation, that is the Cloud Security Alliance, CSA partners. And then we have other security alliance, NIST. NIST is something which many of you must be familiar. NIST is having its IoT device security guidance. There is a series of documentation there, which are, this is what I have put here. There are varieties of documents that is coming in the series called the 8259, 8259B, C, D, all are there. So NIST has a bundle of documentation on how to protect the IoT environment, the security guidelines. So this is also another thing. They have put what is the technical capability required and what are the non-technical capability required. So this is also important. It's not that everything is technical capability, but in today's talk, our focus was on the technology, but the non-technical, like have you documented things, and then whether the information, like if there is a vulnerability identified, do you have mechanisms in place so that it can be reported to the manufacturer, and do they have a mechanism for identifying, fixing it? Like, do people have facilities disclosed by manufacturers for somebody to report vulnerabilities? And how do you disseminate information if you have identified something? Like, that is where we talk about those advisories that is issued from companies, then education and awareness, both customer education as well as the inside the employee education on the developers education, awareness on security practices. All these are covered in this. I don't intend to go into the details of it, but I suggest that you have a look at this, because in the given time, it's not possible. And that's also not my intention here right now. Right now, I would like you to expose you to these kind of frameworks that are available. And they list many technical capabilities, like device identification. Like, have you identified each of those device by a cryptographic mechanism, both logically and physically. That is what the identification. So there are quite a lot of information behind these terms that you are seeing here. So those who are interested, like you, those who know me, you can reach out to me also later on also. Or they are public domain available material. All what I have put here, they are not any kind of behind a paywall or something. They are not paid material. It is publicly available material. So you could pick up that. Even the CSA documents or the NIST documents, IETF RFCs, they are all available publicly. So my aim here is towards IoT security protection. What is out there, and where can you go to find out mitigation practices and then detection practices? What are the best practices available? That is my intention of exposing to this kind of details. And then what can you do? There is also the IETF reference, the RFC. In fact, my today's presentation, that is based on what the IETF is talking. So I did not put it as an explicit reference here, but this whole content itself is based on what IETF is talking as best current practices for securing Internet of Things devices. So there are quite a lot of RFCs there around. They also have the strategic principles for securing Internet of Things. That is one document which you could look at. And RFC 8576, that gives many other references where you can see what IETF is talking. So I would suggest to go through all this. And as a message from my side, there are a lot of things, a lot of practices, and the kind of adversary nature is also evolving. So the defenses are also evolving, and the various industry consortia have come up with the various best practices that can be done. So there is no one magic wand, as I have put there. There is no magic wand. Like if you see your stories always have a magic wand. Like, okay, there was a fairy godmother who stuck the pumpkin with the wand, and then instantly you got a coach, so that Cinderella could go and attend the party. And then for a travel, there is the Cinderella's godmother touched with her magic wand, and then her clothes turned into gold. So she got a nice dress to go, and a vehicle also was there to go. But that will not happen for the security world. So there's no rags to riches story there like Cinderella stories. So you'll have to go through each of these practices, follow defense in depth. And there is enough of material available, and experts are working on. That is how all these are coming out. So keep yourself educated and understand and follow the practices. Questions any from the third section or from anywhere from the presentation?
Can this presentation be shared, ma'am?
Nirupa, what do you usually do?
Yes. We do share this recording in the meetup link, and maybe in a day or two you'll have this recording.
And thank you from my side to Women Who Code, as well as to the organizers like Nirupa and others for organizing the session. I hope it is useful for those in the room.
Thank you, Mini. It was a wonderful session. Thank you very much for your acceptance.
Well, thank you so much.
Yeah.
Thanks that you found it useful.
Yeah. Any further questions to Mini? We have 3 more minutes. Mini, there was a question in the chat. Asked whether the YouTube channels that you used to have the talks. They wanted the links, and you can put that or the chat.
I have put them against my LinkedIn profile in the featured. If somebody is ready to look up that, I think you can do that. In fact, I was trying to make it easily reachable by putting it in my LinkedIn profile.
That's great, Mini. And we do. Yeah, we do have that LinkedIn, your LinkedIn profile in the meetup.
Yeah, you can look at my LinkedIn profile there. I think it is there in that invitation itself, in that meetup link. So I have put links to those recordings in the, as featured post in my list. So you could look at them.
Yeah. And hope we can, people can reach out to you through that channel, LinkedIn channel as well, if they have any queries to you, right?
Yeah. But if there is such kind of detailed session required, then plan another session. Yeah, I don't know.
Yeah.
Like
Hey,
one-to-one
really
doing may not be that effective. Yeah.
true. And yeah, really, Minnie, thank you so much for your for this session. It was very detailed, and you have given us more insights into the life cycle of this IoTs and majorly on a lot of security threats. What variety of security threats that can um, can be posted into this IoT world, right? And also
Yeah.
you introduced us to the industry security disciplines, and yeah, it's lots of information in this 50 minutes. Right. Thank you so much, and
Yeah, welcome.
looking forward for many such.
Yeah, in fact, even my intention from this section is, like I know, like I may not be able to tell so many details in 1 hour, but it was also my intention to expose you to what is available out there, which you could go and pick and then find out for your own.
Yeah, I'm going to tell this to all the audience here that soon Women Who Code is coming up with a series of tech talks on the security, right from the layman to the expert level. We are Women Who Code team is putting out a series of talks, and make use of that. And mostly you look out for that in the month of October or November, and yeah, you please get benefited out of it. Thank you all for joining us this afternoon. Have a good day.
Thank you, all of you. Thanks for your patient listening and attention. Shall I disconnect?
Yes, Minnie, thank you.
Yeah, thank you.